Okay, let's look into question number one. How can you verify that an LLM generated response is grounded in factual and relevant information? Okay, let's look into the options. Option A. Examine the document chunks stored in the vector database. Examining document chunks in a vector database helps backend validation but doesn't directly confirm factual grounding for end users. So option A not the correct choice. Moving on to option number B. Check the reference to the document provided in the response. Verifying cited sources directly ensure the response is grounded and factual and relevant material. So option B might be a potential answer. Let's keep it. Moving on to option number C. Use the model evaluators to access the accuracy and relevance of the response. Evaluators helps access quality but don't guarantee factual grounding in real-time use. So option C not a correct choice. Moving on to option number D. Manually review past conversation to ensure consistency in response. Manual reviewing past conversation ensures consistency but does not verify factual accuracy of the current response. So option D not a correct choice. So option B will be the correct one. Okay, let's look into question number 2. How are fine-tuned customer models stored to enable strong data privacy and security in OCI Generative AI service? Okay, let's look into the options. Option A. Stored in OCI object storage and encrypted by default. Fine-tuned models are stored in encrypted OCI object storage buckets, ensuring data privacy and security. So option A might be a potential answer. Moving on to option number B. Stored in an encrypted form in OCI object storage. Encryption storage violates OCI default store security protocols and best practice. So option B not a correct choice. Moving on to option number C. Shared amongst multiple customers for efficiency. OCI ensure model isolation. Customer models are never shared across tenant. So option C not a correct choice. Moving on to option number D. Stored in OCI key management services. OCI key management stored encryption keys, not our model in themselves. So option D again the wrong choice. So option A will be the correct one. Moving on to question number 3. Which statement describes the difference between top K and top P in selecting the next token in OCI generative AI chat models? Okay, let's look into the options. Option A. Top K selects the next token based on its position in the list probable token, whereas top B select based on the cumulative probability of the top tokens. Top A selects from a fixed number of highest probabilities token, while top B selects from token whose cumulative probability exceeds a threshold. So option is looking a good answer. Moving on to option number B. Top K and top P both select from the same test of set of tokens but use different methods to prioritize them based on frequency. Token selection is based on probability, not frequency, and the set differs dynamically. So option B not a correct choice. Moving on to option number C. Top key and top key consider the sum of probabilities of the top tokens, whereas top P selects from the top key tokens sorted by probabilities. Misrepresented both methods. Top K doesn't consider cumulative probabilities. So option C again a wrong choice. Moving on to option number D. Top K and top P are identical in their approach to token selection but differs in their application of penalties to tokens. So top K and top P use fundamentally different selection strategies, not penalties. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 4. What is the significance of the given line of code? Chat detail service model, OCI generative AI inference model, on-demand servicing model, generative AI model OCL, and Frankfurt Lemach 7 declamancy. Okay, let's look into question number 4. What is the significance of the given line of code? Okay, let's look into the options. Option A. It's set up to the storage location where AI generative response will be saved. A code does not define where responses are stored. It configures model usage. So option not a correct choice. Moving on to option number B. Create a new generative AI model instead of using an existing one. It's reference an existing model via its unique ID, not creating a new one. So option B again a wrong choice. Moving on to option number C. It specifies the service model and assigns a specific generative AI model's ID to be used for inference. Okay, let's look into it sets the service model on demands and link a specific model in inference. So option C might be a potential answer. Let's keep it. Moving on to option number D. It configures a load balancer to request distribute AI inference request efficiency. The code does not involve any networking or traffic distribution logic. So option D is a wrong choice. So option C will be the correct one. Moving on to question number 5. What is the primary function of a temperature parameter in OCI generative AI chat models? Okay, let's look into the options. Option A. Assign a penalty to tokens that have already appeared in the preceding test. Assign penalties to previous used token is a functional of frequency or preservance penalties, not in temperature parameter. So option A not a good choice. Moving on to option number B. Determines the maximum number of tokens the model can generate per response. Control the number of tokens generated per response is a function of max tokens parameter, not the temperature setting. So option B again a wrong choice. Moving on to option number C. Specific a string that tells the model to stop generating more content. Specifies specifies there where generation should stop in function of the stop sequence parameter, not the temperature setting. So option C again a wrong choice. Moving on to option number D. Control the randomness of the model's output affecting its creativity. Control the randomness of the token selection is a function of temperature parameter, directly influencing the creativity of the model outputs. So option D will be the correct choice. Okay, let's look into question number 6. You are using your OCI generative AI chat model to generate response in the tone of a parrot for an existing sales campaign. Which field should you use to provide the context and instruction for the model to respond in a specific conversation style? Okay, let's look into the options. Option A, preamble. Preamble provides system level context and stylish instruction to guide the model tones and behavior. So option A looking a good answer. Moving on to option number B, temperature. Temperature control randomness and creativity, not stylish or contextual guidelines. So option B not a correct choice. Moving on to option number C, seed. Seed influence output determines not conversational style or tone. So option C not a correct choice. Moving on to option number D, truncate. Truncate limits response length and it's unrelated to tones or instruction setting. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 7. In the given code, what does the setting truncate is equal to not do? Okay, let's look into the options. Option A. It ensures the only a single word from the input is used for embedding. Embedding model process full text unless explicitly limited. None does not restricted to one word. So option A not a correct choice. Moving on to option number B. It forces the model to limit the output text length. Transcription applies to input, not outputs. Output length is controlled elsewhere. So option B not a correct choice again. Moving on to option number C. It prevents input text from being truncated before processing. Setting truncated is equal to none ensures the full input text is preserved without cutting tokens. So option C might be a potential answer. Moving on to option number D. It removes all white spaces from the input text. Truncated does not affect formatting or white spaces in input text. So option D not a correct choice. So option C will be the correct one. Okay, let's look into question number 8. Okay, let's look into question number 8. How does OCI generative AI agent ensure the synthesized link to a token URL instead of default stored object stored link? Okay, let's look into the options. Option A, by modifying the RAG agent's retrieval mechanism. Retrieval logic does not control the synthesization URL or metadata does. So option A not a correct choice. Moving on to option number B, by embedding by enabling the trace feature during endpoint creation. Trace help by debugging, not city-size customization. So option B not a correct choice. Moving on to option number C. By increasing the session timeout for endpoint. Timeout setting affects session duration, not city-size link. So option C not a correct choice. Moving on to option number D. By adding metadata to objects in object storage. Customized serialization URLs are assigned by adding metadata to object storage. So option D will be the correct one. Okay, let's look into question number 9. Which feature in OCI Generative AI agent tracks the conversion history including user prompt and model response? Okay, let's look into the options. Option A, agent endpoint. Agent endpoint defines the access point for the agents but not a responsible for tracking conversation history. So option A not a good choice. Moving on to option number B, trace. Logging user prompt and model response for debugging and analyzing a function for trace feature. So option B might be a potential answer. Let's keep it. Moving on to option number C, session management. Session management maintain multi-turn context for conversation continuity, not detailed logging or analysis. So option C not a correct choice again. Moving on to option number D, city session. City session provide source reference for general content, not conversation tracking or history logging. So option D not a correct choice. So option B will be the correct one. Okay, let's look into question number 10. What does a dedicated RDMA cluster network do during model fine tuning and inference? Okay, let's look into the options. Option A, it limits the number of fine tuned model deployed on the same GPU cluster. Limiting model counts in non-function of RDMA. It tied to resource allocation policies. So option A not a correct choice. Moving on to option number B. It increases GPU memory requirement for model deployment. RDMA improves memory access efficiency, not increase model demands. So option B not a correct choice. Moving on to option number C. It enables the deployment of multiple fine-tuned models within a single cluster, enabling concurrent deployment of multiple fine-tuned models in a function of RDMA cluster networking, optimizing GPU resource sharing. So option C might be a potential answer. Let's keep it. Moving on to option number D. Leads to higher latency in model inference. Lead to higher latency is incorrect as RDMA resource communication delays and improve inference performance. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 11. A startup is evaluating and the cost implementation of using the OCI generative AI services for their application, which involves generative text response. They anticipated a steady but moderate volumes of requests. Which pricing model would you most appropriate from them? Okay, let's look into options. Option A, dedicated AI cluster as they offer a fixed monthly rate regardless of usage. Dedicated cluster require minimum hourly commitment and vary by model sizes, not a flat monthly rate. So option A not a good choice. Moving on to option B, on demand inferencing as it allows them to pay per character processing without long term commitments. On demand inferencing charges per character processing and requires no long term commitment, ideal for moderated workloads. So, option B might be a potential answer. Moving on to option number C, dedicated AI cluster as they are mandatory for any text generative task. Dedicated clusters are optional and suited for high volume or custom model hosting, not mandatory for text generation. So option C not a good choice. Moving on to option number D, on demand on demand inferencing as it provides a flat fee for unlimited usage. On demand pricing is a usage based per character, not a flat fee. So option D not a good choice. So option B will be the correct one. Okay, let's look into question number 12. Which role does a model endpoint serve in the inference workflow of an OCI generative AI services? Okay, let's look into options. Option A, evaluates the performance metric of the custom models. Model evaluation is handled separately, not the endpoint itself. So option is not a correct choice. Moving on to option number B. Serves a dedicated point for user request and model response. Serves an interface for receiving user prompt and returning model AI response is a function of model endpoint in a inference workflow. So option B might be a potential answer. Moving on to option number C. Updates the weight of the base model during the fine-tuning processing. Weight updates occur during the training or fine-tuning, not through the endpoint. So option C not a correct choice. Moving on to option number D. Hosts the training data for fine-tuning custom models. Training data is stored in object storage or either repositories, not within the endpoint. So option D not a correct choice. So option B will be the correct one. Okay, let's look into question number 13. How should you handle a data source in OCI Generative AI agents if your data is not ready yet? Okay, let's look into options. Option A. Use multiple buckets to store the incomplete data. Splitting incomplete data across buckets add complexity and it's not recommended for staging strategy. So option is not a correct choice. Moving on to option number B. Upload placeholder files larger than 100 MB as a temporary solution. OCI imposes size limits on placeholder files. Larger files may violate ingestion constraints. So option B not a correct choice again. Moving on to option number C. Create an empty folder for the data source and pollute it later. Creating an empty folder and populating it later allows you to configure the data source in advance and ingest actual data when ready. So option C might be a potential answer. Moving on to option number D, leave the data source configuration incomplete until the data is ready. Incomplete setup prevents agent deployment and delay testing or validation workflow. So option D not a correct choice. So option C will be the correct one. Okay, let's look into question number 14. What source type must be set in the subnet ingress rule for the Oracle database in OCI Generative AI agents? Okay, let's look into the options. Option A CIDR. CIDR specifies a range of IP address allowing secure and flexible access for the agent subnet to the database. So option A might be a potential answer. Moving on to option number B, public internet. Public internet exposes the data of all external traffic, posing major security risk. So option B not a correct choice. Moving on to option number C, security group. Security group defines access rule but are not used directly at source type in subnet ingress rules. So option C not a correct choice. Moving on to option number D, IP address. A single IP is too restrictive and impractical for dynamic or multi-agent access scenarios. So option D not a correct choice. So option A will be the correct one. Okay, let's look into question number 15. What happens when you delete a knowledgeable base in OCI generative AI agents? Okay, let's look into the options. The knowledgeable base is archived for later recovery. OCI does not have archive deleted knowledge bases. Deletion is final. So option is not a correct choice. Moving on to option number B. The knowledge base is marked inactive but remains stored in the system. Knowledge base is not retained in any inactive state, it fully removed. So option B not a correct choice. Moving on to option number C. Only the metadata of the knowledgeable base is removed. Deletion removes both metadata and content, not just metadata. So option C also wrong choice. Moving on to option number D. The knowledge base is permanently deleted and the action cannot be undone. Deletion a knowledgeable base in OCI agents, AI agents is irreversible and removes all associated data. So option D will be the correct choice. Okay, let's look into question number 16. In OCI generative AI agents, if an injection job process 20 files and 2 fails, what happens when the job is restarted? Okay, let's look into the options. All 20 files are re-ingested from the beginning. Successfully ingested files are skipped during restart to optimize processing. So option A not a correct choice. Moving on to option number B. Only the two failed files that have been updated are ingested. Restarting the job triggers ingesting only the previous failed files that have been since been updated. So option B might be a potential answer. Moving on to option number C. The job process all 20 files regardless of updates. OCI avoids redundant processing by skipping already ingested files. Option D not a correct choice. Moving on to option number D. None of these files are processed during the restart. Restarting the job processing eligible field files, not an empty run. So option D not a correct choice. So option B will be the correct one. Okay, let's look into question number 17, which is the cost related benefits of using vector database with large language models, LLMs. Okay, let's look into the options. Option A, they increase the cost due to the need of real-time updates. Real-time updates are efficient and do not inherently raise cost when using a vector database. So option A not a correct choice. Moving on to option number B, they offers real-time updates knowledgeable based and are cheaper than fine-tuned LLMs. Vector database enable dynamic knowledge retrieval and are not cost efficient than retraining or fine-tuning LLMs. So option B might be a potential answer. Moving on to option number C. Vector databases are more expensive but provides higher quality data. Quality depends on the data curation, not cost. Vector databases are typically more affordable than fine-tuning models. So option C not a correct choice. Moving on to option number D. They require frequent manual updates, which increase operational cost. Vector database support automated updates via embedding, reducing manual overheads. So option D again a wrong choice. So option B will be the correct one. Okay, let's look into question number 18. How does the use of a vector database with retrieval argument generative based large language model fundamentally after their response? Okay, let's look into the option. It transformed their architecture from neural network to a traditional database system. RAG enhanced LLMs with retrieval, but the core natural architect remained unchanged. Okay, let's look into option number B. It enables the bypass the need of pre-training or large text corpora. Pre-training is still essential. RAG supplements it with external knowledge, not replace it. So option B not a correct choice. Moving on to option number C. It limits their ability to understand and generate natural language. RAG improve contextual relevance and reduce has high hallucination, enhancing language generation. So option C again a wrong choice. Moving on to option number D. It shifts the basis of their response from static pre-trained knowledge to real-time data retrieval. RDG uses vector database to inject fresh, relevant data from LLM prompts and replacing static only knowledgeable. So option D will be the correct choice. Okay, let's look into question number 19. Which is the main characteristic of greedy decoding in the context of language model word predictions? Okay, let's look into the option. Option A, it chooses words randomly from the set of less probable candidates. Greedy decoding avoids randomness and always select the top ranked tokens. So option A not a correct choice. Moving on to option number B, it requires a large temperature setting to ensure diverse word selections. Temperature turning applies to sampling methods, not greedy decoding. So option B not the correct choice. Moving on to option number C, it selects word based on a flattened distribution over the vocabulary. Greedy decoding uses the original prompt distribution, not flattened ones. So option C not a correct choice. Moving on to option number D, it picks the most likely words to emit at each step of decoding. Greedy decoding selects the highest probability token at every step, producing deterministic output. So option D will be the correct choice. Okay, moving on to question number 20. How does a large model LLM decide on the first token versus subsequent tokens when generating a response? Okay, let's look into the options. Option A. The first token is randomly selected while subsequent tokens are always chosen based on the input prompt alone. Token selection is probabilistic but not random. it based on the prompt. So option is not a correct choice. Moving on to option number B. The first the token is selected using only the model past response, while subsequent tokens are generated based on the input prompt. LLM does not use prior conversation unless explicitly includes in the prompt. So option B not a correct choice. Moving on to option number C. The first token is selected solely based on the input prompt, while subsequently tokens are chosen based on the previous token and the input prompt. LLMs use the input prompt for the first token, then generate each subsequent token based on both the prompt and previous generative tokens. So option C might be a potential answer. Moving on to option number D. The first token is chosen based on the probability distribution of the model entire vocabulary, while subsequent tokens are created independently of the prompt. All tokens are contextual grounded in the prompt and prior outputs. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 21. An AI development company is working on an advanced AI assistant capable of handling queries in a seamless manner. Their goal is to create an assistant that can analyze images provided by users and generate description text as well as take text description and produce accurate visual representation. Considering the capabilities, which type of model would be company likely focus on integrating into the AI assistant? Okay, let's look into the options. Option A retrieval augmented generative model that uses text as an input and output. RAG enhance textual response using external knowledge but does not support image generative generation or analysis. So option A not a correct choice. Moving on to option number B, a diffusion model that specialized in producing complex output. A diffusion model is specialized in producing complex output. So option B might be a potential answer. Let's keep it. Moving on to option number C, a language model that operates on a token by token output basis. A token by token output language model generate text sequential but lacks native support for virtual visual input and output. So option C not a correct choice. Moving on to option number D. LLM agents specialize in textual reasoning, not multimodal tasks like image caption or synthesis. So option D not a correct choice. So option B will be the correct one.